Okay, so let's start this webinar. Again, thank you for joining. We will deal with some exploration of design region of the optimization calculation in JMAG, and mainly one of the main new feature of V22 of JMAG Designer. So the agenda for today: first, motivation. Then we will have a look to the rangefinder, which is kind of a new feature. Optimization, we'll see that also one new feature is important in the optimization process, and a brief summary. So just before completely starting, feel free to ask your question in the Q&A panel. I will try to answer as much as possible at the end of this session. Let's move to the motivations. So the optimization of the electrical motor now becomes more and more complex. We've got several design variables. In a previous webinar, we have seen that if we made some trade-off kind of sensitivity analysis, maybe we will try to optimize one variable and then we will reduce the loss, but then we'll increase the torque ripple, something like that. So those trade-offs are not so easy to be made, and maybe it will lead to some wrong optimization. So maybe not easy because of those several design variables now. Also, the range is a key and is very critical. The design range has to be large. In this same previous webinar, we have seen some techniques to narrow down the design space last year. And you can see that depending on the techniques, what you are doing after you're narrowing down, maybe you also miss some good results and some good design, and then you don't have the most accurate and appropriate results. So we are going to try to overcome those issues in the designer with some design exploration, and by applying those design exploration, many prototypes and evaluation will be simulated, and this is much more shorter than making some actual measurement. So about the optimization issue, briefly, of course, now the large number of design parameters. So here you can see a sample example. So this one have more, this is just the rotor, but you've got also some for the stator. So more than 25 variables here. So you will have also wide range for all those parameters, but maybe those wide range will make the shape collapsed like that with some overlapping regions. And also we also still have some many output like torque, loss, stress, and different operating points to be considered. So optimization is not new in JMAG. We add, for example, this very classical optimization. This is a model which could be downloaded in the JMAG application catalog. You've got the number here. Okay, all those feature was already embedded. The thing is that in that case here, if you check in the optimization, you've got 1, 2, 3, 4, 5, 6 design variables. So the amount is relatively small, and you can see that the design of the rotor is not so complex. You can also see that you can already make some group of studies. So in fact, here are your models, your model in JMAG, and you've got different studies. This one is for searching beta. So you can see that this is a classical model in JMAG with this motor induction condition, which is in fact the condition for searching the beta. Here you see beta max and beta min for one single current amplitude. So now I'm going to search for the best beta for my torque, for example, in this study. Then in the next study, I will maybe calculate my corresponding torque. And here you see I've got this response graph data, torque average is outputted. And also I've got the last study, which is structural. So it's now checking the stress, maybe in the bridges here. So you can see that all those things was already possible in JMAG. Different study that could be grouped in this parameter group. So you see that my studies are listed here, and all the response data coming from the different studies are displayed here. And I can now make the optimization and the objective function based on the response graph data coming from the group. So it means coming from different studies. So different physics, different numbers of parameter, everything was already possible. The thing is that now with this huge amount of design parameter, the shape will collapse. And if you've got more than 20 parameter, you will have a very small success ratio of a variable design sets of parameter that gives a valid geometry. So in another tutorial, I'm going to show you that later, but there is a tool in JMAG to allows you to check how much success rate you have. And for this example, you see that the success rate is, okay, maybe its definition is not so good, but like this, is 0.08%. So definitively, you are going to lose some time, and the effectiveness of your optimization will be very poor, because you will have some very few successful shape to be run in the optimization process. So we are going to introduce some genetic algorithm, which is also a multi-objective optimization engine. Okay, but this time, this genetic algorithm will be used not only in the main optimization process, but in the shape, in the creation of the shape, and trying to get the minimum and maximum of each design parameter to get a valid shape, a valid geometry, with no region overlapping or something like that. No geometry collapsing. So here you've got the process of the genetic algorithm. Briefly, it's generating some candidates and just keeping the one that are valid, and from the remaining one, adding some new generation after generations. So it means that now we are going to use this GA for the range finder function in JMAG, and so that you don't even need to put some minimum and maximum values. JMAG will do that for you. In addition to that, JMAG will also create predictive model, or it's also called predictive model, so that with a specific amount of geometry already tested, JMAG will be able to guess in advance if those new sets of parameters will give a valid geometry or not. The rangefinder is taking care of the mean and the max, but when you've got many parameters, maybe in the middle of those range, there are possibly some values that will give also a non-correct shape, destroyed shape. So this predictive model will take care about that inside the range. Now JMAG will be able to guess and to know if that will be a valid geometry or not. Of course, this predictive model is based on already data, experience data. JMAG will create cases in advance. If if you put in the learning model very few cases, of course, the guess of JMAG will be wrong. You need to put enough data in the predictive model, in the training model, and then JMAG will be able to guess correctly if the new amount of the parameter will give a correct geometry, a valid geometry or not. So with all those tools, the combination of rangefinder and predictive model, you can see here the comparison between the random search, which is the classical one, and so the rangefinder plus predictive model. So you can see that the entire process time for the optimization is much more lower. So let me come back to this model here that I show you briefly in the slide. So this predictive model and rangefinder is not completely new in V22. It was already existing in JMAG in V21.2, but you had to use some pre-installed script. So you had to use the this is the rangefinder, but using the pre-installed script. So you had to use free script. This one create cases and create predictive models. So you had to use those free scripts. Now the good news is that this is embedded in the JMAG graphical user interface. So if you go to your optimization windows, and if you go to option, okay, it's already checked. So you can now have an access to this rangefinder. No, okay, anyway, I'm not going to use the zoom. Anyway, this is the parameter you have to check here. So this one will also will use those new tools, and you can keep those set parameter automatically. In case you would like to change it, you can change it. So that's the amount of data you would like to use for the learning model, the predictive model. And also, you can also use this advanced search range here. So if you check that box, JMAG will also be able to extend this range and to really go deeper in the optimization and make your optimization more effective by checking this new rangefinder. And you can check the one JMAG will be able to modify, or if there are one you really don't want to be changed and to forced with your own values, then you can, for example, uncheck and JMAG won't change it. Of course, this new feature is also coming with the management system of JMAG. This is the user job management of JMAG. So you can use this one also. Yes, so it means that JMAG will run all the job smartly to really save some calculation time. Let's go back to the slide. So the advantage of the rangefinder is to ensure that the creation of non-overlapping region, to avoid error in the optimization, able to search in a wider range, because now JMAG will detect this range automatically. And then, of course, you reach optimal design faster, but not only faster, I mean, your efficiency will be much more good, much will be best with this rangefinder because the range will be very adequated, and the Pareto front will be very optimized using this tool. So of course it will be faster. I mean, optimal design will be faster, but the optimization calculation process maybe not so faster, because the goal here is to get a better Pareto front, not to go much more quicker. I mean, here is the examples I presented you. So design parameter 25, we had 25 parameter here. Optimization, so you can see all the parameter. Okay, 22, maybe that's not exactly the same examples. Objective function 8, number of generation, population, total number of cases to be evaluated, and then you can see the evaluation criteria also here. Here is a small picture here, an overview of the results. So you can see here torque ripple versus torque average, and you can see that the feasible design are, one of the feasible design are here, for example. And you can also see an overview here of the different results and different shape with the values. So you can review the values of the of course of the input, and you can also review the min and max, the range that JMAG has created for you. So by doing this is something I already done, so I just show the procedure. So if you go to optimization, here you can import the file that JMAG has created for the min and max, and here you can see it has already been updated. You see there's many digits, so you can also check what min and max values has been used for the optimization. So what is the range, final range used for the optimization, the results of the range finder, in fact, not only the results for the optimized design, but the value of the range obtained by the range finder. So summary, yes, we have achieved some exploration of design space with rangefinder. So we've got some, we ensure that we've got some valid geometry. We also use the predictive model to get optimal solution faster compared to the random search, okay? And also this will be very useful to get a more effective, to improve the effectiveness of your optimization. Of course, calculation time should be better, but the goal is here to really go further in your optimization and to get much more effective optimization and get better design. Okay, so thank you for listening. I hope you have a brief introduction of this new feature of JMAG. I encourage you to check this new tutorial, which is available on the JMAG website. You can just type GFT 164. And yes, please use it with the new version of JMAG, version 22, which is also available on the website. And you will be able to test it, this new feature. I mean, the embedded rangefinder and the predictive model embedded in the graphical user interface. Now, no need to use those scripts. Okay, so I can see that we have one question. How can rangefinder find the range for each variable when the range is dependent on other range with other variables? Yeah, so that's okay. Maybe I can read louder the question. How can range finder find ranges for each variables when the range is depending on some other range for other variables. So that's exactly the purpose of this slide here, explaining the genetic algorithm. So this genetic algorithm is in fact a multi-objective optimization. That's kind of an optimization inside the optimization. So JMAG is going to see which trend of the variables leads to a good shape, a valid shape. And this genetic algorithm is very good in detecting in objective functions that are like minimizing and maximizing variables when each other are competing with other one. For example, increasing this magnet will reduce the range of the bridge, for example, something like that. So that's the goal of this genetic algorithm, to evaluate and to detect this minimize and maximize values for the variables. And that's as I said, it's a multi-objective optimization inside the whole optimization. So you've got the whole optimization, the big optimization that will lead to finite element calculation, outputting the torque and etc. But before that, another optimization, multi-objective optimization, will be done just using the modeler. The modeler is the shape creation of JMAG. So just using the CAD design, a multi-objective optimization will be made on the input variable to try to determine which is the minimum and maximum size, depending on the other one, of course. That's why it's a multi-objective, because you've got multiple variables and maybe one variables try to reduce the other one, something like that. So I hope I have replied to this question. Another question is that for a certain design, is JMAG able to quickly determine the shape is valid or not? Yes, I think that's the predictive model. So the predictive model, okay, maybe I don't know if I have some valid test here, but you see this output file will be generated, and in fact JMAG will check if you've got for any parameter the results, and will check if this is valid or not valid. No, that's not the correct. I don't know. I don't have the data right now. But yes, the answer is yes, and that's the predictive model. So predictive model or learning data. So JMAG will take some values for the variables, and the CAD will just reply that yes, it's valid, or no, it's not valid. So there are several criteria for that. Like JMAG is checking if there is any region overlapping, how many lines, points are there. If there is less or more, it means that maybe there are some collapsing or something like that. So yes, that's the predictive. That's the predictive model or e-learning model. There are different names. Yes, that's the and you need to put specific enough amount of data, amount of trial, in fact, in this learning model, and based on some mathematical formula, JMAG will be able to guess with any other different values, set of values, that if this will be valid or not valid. Does this feature available in JMAG v20.1? No, I don't think it's available in v20.1. As I said, you need to have at least v21.2, and you need to use the script if you would like to have the embedded function in the graphical interface. As I showed previously, you need to go to v22. Okay, that's two questions. How does this algorithm balance with witness of each design parameter? Okay, so maybe now, okay, let me read the question. How does this algorithm balance the weight in of each design parameter? It seems the impact of each parameter on objective function is not evaluated. So that's a different process in the optimization. This genetic algorithm, the one we are talking right now in this slide, is the one for getting the minimum and maximum values for the parameter. And it is just checking if the shape is valid or not valid. It's not dealing with the whole optimization, trying to maximize torque, minimize loss, and something like that. This one is this is possible, but it's a different. Here you see, it's a different things. I mean, it's not related. In the objective function, in the whole, in the main optimization process, yes, you can put some weight and you can prioritize if you would like the torque average to be more important than torque ripple, for example. So yes, you can do that. But the one I'm presenting now, which is used in the rangefinder, it's not dealing with the main objective of the optimization. It's just checking if it's valid or not valid from the shape point of view. How design parameter sensitivity to objective function is incorporated? I guess that's the more or less same question. How design parameter sensitivity to objective function is incorporated? Yes, I think if I well understood, for me, it looks like the same question. So here also you can prioritize in the optimization, in the objective function, you can prioritize and put some weight so that some objectives are more important than another one. Okay, if I misunderstood the question, feel free to contact us. You can contact me by email directly or use the JMAG support email address. No problem. Okay. Seems we don't have more questions. So I will stay connected, maybe 4 to 5 minutes in case there are some more questions. And if no more questions, we will, okay, one more question. Yes, exactly. The weight function you define is for objective function. Yes, exactly, yes. Okay, maybe, yeah, feel free to contact me by email. We can continue the discussion because maybe there is something I'm not fully understanding, but yes, okay, we can continue the discussion, no problem. How the parameter is related to these objective functions. I'm saying that how the parameter is related to the objective functions. The parameter are then here. So now I get the mean and the max, and now in that range and using the predictive model also, I will now run my main objective main optimization, and those resulting data will be used with this kind of weight, will be used in the main optimization. For example, while changing many parameters, then how it will be prioritized. Okay, so maybe your question is not really about rangefinder or predictive model, but maybe more about directly optimization of JMAG, and you would like to know the optimization process or the optimization formula that are used then to achieve the objective functions, depending on the weight, of course, and how you are going to change the variables. So it's more about the main process, the main optimization process of JMAG. I think we can continue this discussion. So you can contact me and maybe I can try to find some more information. As far as I understood, your question is more related, yes, to the main optimization process of JMAG, not so much about the rangefinder and the predictive model I have presented right now. So maybe we can continue the discussion outside the webinar. Okay, I will stay connected anyway, a few minutes, if there are any other questions. If no more question, then thank you for joining and for listening this webinar. Feel free to test the new version of JMAG and this new feature. And thank you again and bye. I will stay connected anyway, few minutes. Okay, so we will end the session. And I think we have your email address, so we can continue the discussion outside the meeting. I will now close the webinar. Thanks again for joining.